Hello, class. I just want to go over some notes for 3.2. So I know it's kind of hard to see. This is like a packet of notes. This is 3.2. I know it's hard to see. This is 3.2 differentiability. And I want you to copy these notes down. So basically what this section is all about is how things can either be differentiable or not. And I want you to actually write all the stuff down. You can pause if you need. You don't have to do the Post-it notes. These Post-it notes are for me, for notes for myself. So I'm just going to read this out loud. Recall from 3.1 that you have a function with two different derivatives on both sides of a point. So if you just watched the video or you recall back to our last lecture, we were talking about derivatives from both sides, and if they agree, if they're like the same derivative from the left hand and the right hand derivative, then the point should have a derivative. But if it does not, if it has two different derivatives, then that point should not have an overall derivative there. So here's some, I know it says how f prime of a, but we'll just put f prime of x, okay? The f prime of x might fail to exist. There are four ways, okay? And this is page 111, that's what that says. You have corners. So corners is, what is it? That's indicative that you have an absolute value function. And you can kind of tell the one side derivatives will definitely differ. This is probably the most apparent way to look. Let's just say that this is -1 slope, linear slope, and then here this has a +1. So you can definitely tell their slopes when they meet are going to be +1, -1, or even +1, or yeah. So yeah, that's exactly what's going to happen here. So there should be no derivative that exists there. Cusp are another ones. They're pretty much just like corners. Cusp and corners, I think, are very, very identical. So go ahead and copy this down too. F of x is equal to x to some kind of fraction. So you have some kind of fraction exponent, typically, but not necessarily always. So that's when the slopes of the secant lines, or just your lines, approach from positive infinity from one side and negative infinity from the other, like another crazy corner. They meet here. So it's like I call it a crazy corner, not just a corner, but a crazy corner, because the slopes, if you can kind of see, they're going almost vertically down. And all of a sudden, when you're coming from this side here, they should come vertically down as well. So that's another crazy one here. Or actually, if you think about it, yeah, I don't know. That just doesn't work. And then vertical tangents are sort of, it's a little bit different, but you have an odd root, so, or like another fraction, I guess, like another depending on what kind of fraction that you have. Another fraction that you have a sort of curve here where if you look really closely at the middle of this vertical curve, you have it approaching positive infinity, and then coming down from the one other side of a point, you have negative infinity. So that's what we call vertical tangent. And of course, the easiest thing to spot is the discontinuity. So that's where you have completely different slopes. So this would be a slope of, like, let's say -1 or something, and then this would be a slope of +1, and or just, yeah, you just see that they're different constants and they don't even match, they don't even touch. They're not going to have any sort of derivative there. Okay. All right, guys, so I'll work on one more thing with you in the next video. That's pretty much all I had to say for identifying. So I think numbers 5 through 10 or 11 through 16. Those are the questions that are going to kind of go through the things that you see here. Okay, I'll see you in the next video. Bye.